equation is double pendulum. So double pendulum, as you can see in the figure, it consists of two mass. The first one is M1 and the second mass is M2, and M1 is held by a body of length L1 and M2 by length L2. So if you want, there is so you can see the figure of a double pendulum.
So this is a double pendulum. That's two nice stable rods along the
So this is a double pendulum. There are two masses held by a rigid body. That is like this. And the diagrammatic picture is here.
So they're out of phase. And also it's a bit faster, it's nice and stable.
And a double pendulum will give us a chaotic motion. That is something different. So I just inform you. So here also in the same way we are finding Lagrange's equation, and for that first we have to find kinetic energy and potential energy. So equation is L is equal to T minus B. Here we have two objects and we will have two generalized coordinates, and hence we will have to find two equations. This is somewhat complicated. So let us try. First one, we have to find the kinetic energy. So T1 will be T is equal to half m x1 dot square plus y1 dot square. So for T1 we have to find x1 and y1. So what is x1? This is our x1. So the value for x1 will be L1 sin theta. L1 sin theta 1. And y1 will be L1 cos theta 1. And here our equilibrium point we are taking over here. This is our equilibrium point. So this will be positive y, and downwards we will have negative y. Here positive x, here negative x. So our y downwards will be negative. So we will give a negative sign. Y1 is equal to L1 cos theta 1. So that is our x1 and y1. Now we are finding x1 dot and y1 dot. So what will be x1 dot? Yes, it will be L1 cos theta 1 dot theta 1 dot. Then in the same way y1 dot will be L1 sin theta 1 into theta 1 dot. The minus and the minus for this term will get cancelled. Then we have to find P1 is equal to half m1 into this term. Square of this term is L1 square cos square theta 1 into theta 1 dot square plus L1 square sin square theta 1 into theta 1 dot square. So this is our kinetic energy, that is T1. Then next is T2. T2 is for the second mass. So for that we have to find x2. So what will be x2? This is x2. That means this x1 plus this one. Understood? So x1 plus this term, and this term we will get using this part of the figure. So what will be this term? Yes, it will be L2 sin theta 2. So L2 sin theta 2 plus this part. Then only we will get the total. So plus x1. x1 is L1 sin theta 1. So this is our x2 term. And similarly y2 term will be y1 plus this part. So it will be, first we can write y1 minus L1 cos theta 1 theta 2. So this is our y1, y2 and x2. So we have to find y2 dot and x2 dot. So x2 dot will be L2 derivative of sin theta is cos theta 2 into theta 2 dot plus L1 cos theta 1 into theta 1 dot. So this is our x2 dot. In the same way we will have our y2 dot also. Y2 dot will be equal to minus L1 minus of minus, that means for cos it will be sin, so it will be L1 sin theta 1 into sin theta 1 dot. Again minus and minus will get cancelled and become plus L2 sin theta 2 dot theta 2 dot. So this is our y1 and y2. Next we have to square this and add. So this one. So x2 dot square is equal to, this is our x2 term, and on squaring we have to, this is single term, so it will be whole square. So we have to use a plus b whole square for this term. So it will become L square cos square theta 2 dot theta 2 dot square. This is a square. Then b square, here we have L1 square cos square theta 1 dot square plus 2ab. It will be 2 L1 L2. These two terms. Then we are writing these two terms. L1 dot L2 dot, then cos theta 1 cos theta 2. So this is our x2 dot square. The similar way we have to find y2 dot square. It will be L1 square sin square theta 1 into theta 1 dot the whole square plus L2 square sin square theta 2 dot theta 2 square plus 2ab. 2 L1 L2 theta 1 dot theta 2 dot sin theta 1 sin theta 2. This is our y2 dot square. So on adding both this, we will get our t2 this term. So on adding t2 is equal to half m2 x1 dot square plus x2 dot square plus y2 dot square. So we are adding this and this. Here you can see L2 square cos square, this term and this term. They are similar, right? They are having common terms. So when we are taking outside, L2 square is taken outside and this thing is also taken outside. So inside we will have cos square theta 2 plus sin square theta 2. That is 1. So the leftover will be half m2 into L2 square theta 2 dot square. So this will be left out. So this term is gone. Then in the same way here also, So this is also gone. This is also gone. And in these terms you can see all these are common. 2L1, L2, theta dot 1, theta dot 2, all are common. So we are taking them outside. So it will be 2L1, L2, theta 1 dot, theta 2 dot, and inside we will have cos theta 1, cos theta 2 plus sin theta 1, sin theta 2. So we will be having like this, and I am writing this. This is in the form of a trigonometric identity. Cos A, cos B plus sin A, sin B. So here we will have cos A, cos B plus sin A, sin B is equal to cos A minus B, cos A minus B. So when we apply that, we will have our total T is equal to half m2 into L2 square cos theta 1 minus theta 2. So this is our T2 plus our T1. What was our T1? T1 is half m1 L1 square theta 1 dot square that we found from the first object. So here you can see this L1, this term and this term, they are similar. So I am taking it outside. So we will have total T is equal to half. If I am taking this and this one outside, the leftover will be half m1 plus m2. So m1 plus m2 and these terms L1 square theta 1 dot square plus this into this into this, half L2 square theta dot square plus this 2 and this 2 will get cancelled. So we will have m2 L1 L2 theta 1 dot theta 2 dot cos theta 1 minus theta 2. So this is our kinetic energy. Hope this is clear. So next is we have to find the potential energy. Potential energy is far simple than this. So for that we have V is equal to mg into height. So for V1 it will be mg y1. So y1, our equation for y1 was minus L1 cos theta. So it will be V1 is equal to minus mg L1 cos theta 1. So this is our V1, and V2 it will be mg by 2. So it will be mg into our y2 is minus L1 cos theta 1 minus L2 cos theta 2, because the y1 plus the other. So like this, and if we want we can open that. So our total V here. So it will be minus m1 plus m2 g L1 cos theta 1 plus minus m2 g L2 cos theta 2. Is that clear? Is there any doubt? Like we are expanding this. So it will be m2 g L1 cos theta 1, m2 g L2 cos theta 2. And here L1 cos theta 1, here also L1 cos theta 1. We are bringing them together. So it will be minus m1 plus m2 and gl1 cos. So this is our potential energy. Now we have to put this in our equation. T minus V, and T is here and V is here. So our L will be half m1 plus m2 L1 square theta 1 dot square plus half m2 L2 square L2 square dot square this term minus of minus will become plus. So m1 plus m2 gl1 cos theta 1, again minus of minus, so it will be plus m2 gl2 cos theta 2. This is our Lagrange formula. So we got our L. Now our L as this. Now we have to substitute this in our Lagrange equation. So I will write this. Our Lagrange equation is d by dt of here you can see there are two variables, theta 1 and theta 2. So there are two generalized coordinates and we want to find equation for both theta 1 and theta 2. First we are finding for theta 1. For theta 1 it will be dou L by dou theta dot minus dou L dou theta equal to 0. So first we can find dou L by dou theta. So the theta terms are theta 1 terms. This is theta 1. Theta 1 terms are present in this one and in this one. So we have to find the derivatives of them. So it will be m2 L1 L2 theta 1 dot theta 2 dot, and derivative of cos is minus. So minus sin theta 1 minus theta 2. So this is the derivative with respect to theta 1 for that term. Plus this plus m1 plus m2 g L1 minus sin theta 1. So this minus I will be writing here. L1 square theta 1 dot plus in this term N2 L1 N2 theta 1 dot is we are finding the derivative. So we have theta 2 dot into cos theta 1 minus theta 2. So this is our dou L by dou theta 1 dot. So this is found. This is also found. Now we have to find the time derivative of this one. D by dt of dou L by dou theta 1 dot. And for that, we will have the derivative as m1 plus m2 L1 square is theta 1 double dot, because theta 1 is d theta by dt. So on doing derivative again it will be d square theta by dt square. So theta double dot plus in this term we can see that this is a function of time and this is also a function of time. So we have to use the product rule there. So all the things we can place outside m2 m1 m2 and the product rule will be first function theta dot 2 into derivative of second. In order to find the derivative of this term, we have to use the substitution method. So we are given theta 1 minus theta 2 is equal to u. Substitution method. So du will be du by dt will be theta 1 dot minus theta 2 dot. And then we are finding here cos u d by dt of cos u. We have minus sin u into du by dt. So we will substitute this thing here. So it will be minus sin theta 1 minus theta 2 into theta 1 dot minus theta 2 dot. So that will be the derivative of this term. So we are writing it into sin theta 1 minus sin theta 2 into theta 1 dot minus theta 2 dot. Then plus derivative of first term. Derivative of this term will be theta 2 double dot and the second term cos theta 1 minus theta 2. So this is the time derivative of this one. So we got all the terms for our equation. Now we are substituting it into our Lagrange equation. So it will be, so we are expanding this term. So we have m1 plus m2 L1 square theta 1 double dot square plus we are expanding these terms. So for this we will be doing this theta 1 dot into this plus theta 2 dot into this. So it will be, this was already outside. theta 2 cos theta 1 minus theta 1 minus theta 2. So this is our d by dt of dou L by dou theta 1. Now we have to substitute all this in our this equation. So for that, theta 1, our equation for Lagrange will be m1 plus m2 L1 square theta 1 double dot plus m2 L1 L2 theta double dot 2 cos theta 1 minus theta 2 plus m L1 L2 theta 2 dot square sin theta 1 minus theta 2 plus L1 plus m2 g L1 sin theta 1 equal to 0. This is our Lagrange equation. Now what we have to find is acceleration. So for theta 1, the acceleration is in this curve. So dot will be equal to all these term divided by m1 plus m2 L1 square will be equal to all this divided by m1 plus m2 into L2 square. This is the equation of motion. This is the equation of motion for our theta 1. In the same way we have to do for our theta 2 as well. For theta 2, it will be this equation. Generalized coordinate is theta 2. So first we have to find dou L by of this form. Now we have to find dou L by dou theta 2 dot. So it will be in the form of m2 L2 square theta 2 dot plus m2 L1 L2 theta 1 dot cos theta 1 minus theta 2. Then we have to find the time derivative of this one. In the same way as we did, we have to take product put and find the thing, and the answer will be of the form m2 L2 square theta double dot square plus m2 L1 L2 theta 1 double dot cos of theta 1 minus theta 2 minus m2 L1 L2 theta 1 dot square sin theta 1 minus theta 2 plus m2 L1 L2 theta 1 theta 2 dot sin theta 1 minus theta 2. So this is our time derivative for this theta 2. Now we have to combine this to form our Lagrange equation, and our equation will be like m2 L2 square theta 2 double dot plus m2 L1 L2 theta double dot 1 cos theta 1 minus theta 2 minus m2 L1 L2 theta 1 dot square sin theta 1 minus theta 2 plus m2 g L2 sin theta 2 equal to 0. So this is our Lagrange equation of motion. This is our Lagrange equation of motion, and our aim is to find the acceleration for this theta 2. So we are bringing all the terms to the other side such that it becomes this is equal to the whole into 1 by m2 L2 square. So this is our equation of motion for the particle m2 which is having an angular displacement of theta 2, and both the equations are given there. So this is about the Lagrange equation for a double pendulum, and in this class we had talked about acute machine, simple pendulum and double pendulum, and that's all. Other applications will be taken in the next class.